In our last video, we got introduced to the math class, which has several methods or functions or procedures. You can think of them as commands that help us do math operations. Weird things like sine and cosine are found in there, but simple things like exponents, right? We can do exponents with Math.pow. All that is found in there, and we're going to pick up there by coding something known as compound interest. Compound interest is added to the principal or initial amount of a deposit or loan, in which future interest is added based on the total amount, including principal and interest. This doesn't mean hardly anything to me. Okay, we're going to write a program that prompts a user to enter a principal amount, interest rate, number of years, and number of times compounded per year, then use the compound interest formula to calculate the growth. Here is the compound interest formula. So what it is you're going to, in theory, deposit money. Right? There's an interest rate, meaning that money would grow. But it's more than that, because as the money grows, the interest rate applies to that. That's what compound interest is. Okay, so here I have the formula and we're breaking it apart. P is going to be my initial amount. R is the interest rate in this case. N is the number of times compounded per year, and T is number of years. Notice we got some exponent nonsense going on here. So we're going to write a program that's going to get these four values from the user, and we'll calculate compound interest. Okay, this would be a good spot to kind of pause. Actually, enlarge the slide again. This would be a good spot to kind of pause if you want to attempt this on your own. That's something I kind of recommend. Otherwise, buckle up, because here we go. I'm an IntelliJ, and we're going to make a new project by going to File, New Project. We're going to call this one Compound Interest. I'm going to expand my project folder, right-click on the SRC, do a new Java class. I'm calling that Compound Interest. Yeah, a little copy and paste action there. It was kind of sneaky, wasn't it? We're going to plug in our main method. Public static void main string with a capital S, brackets, args. I'm going to go ahead and implement scanner. Our first step is, let's import java.util.scanner with a capital S. My second step is going to be, let's create our scanner object. Sorry, I was thinking if I wanted to do like an intro statement or not. So I've created a scanner object here, which I'm calling input. Doesn't have to be called input, right? This is just a variable name. It's what you want to call it. Input happens to be one of my favorite. KB is another popular one, indicating that it's coming from the keyboard. Our third step is to prompt the user. Right? The first thing we're going to ask for is our principal amount. So I'm going to do systemout.println. Please enter the principal amount. Okay? And this is kind of what I mean. When we get to this point, they're like, what is even going on? If you sit someone down in front of the computer and tell them to try out your program, maybe the program should kind of iterate what it's doing. This program calculates compound interest given four values. Principal amount, maybe we write out our variable names here. Okay, you can see where this is going, and I know some of you are so ready to copy and paste. I'm going to throw you a bone. This systemout.println happens all the time, right? I'm doing lots of print statements. So much so, it would be super awesome if we had, I don't know, a short key. We do. All IDEs are going to have short keys for various things, and systemout.println is one that's so common that there is a short key. The short key in IntelliJ is sout. I'm going to type in sout, or sometimes I've heard students and myself say sout, and hit enter. and IntelliJ will auto-complete the rest of that. Let's finish this out. We're going to do more, right? Our principal amount, that's one thing that we want. We want our interest rate. I'm going to specify R for that. I'm ready for a new system.print line, so I'm going to go S out, hit enter. There it is. Times compounded per year. Which is going to be expressed as N, SOUT, number of years, which is T. So these are the four values that I'm coming in with, right? This program calculates compound interest given four values: principal amount, interest rate, times compounded per year, and number of years. Please enter the principal amount. Should this be capitalized? I don't know, right? I capitalized it up here. Maybe it should be capitalized down here. All right. We're asking for a principal amount. I want you to think about data type. What could that possibly be? We're talking about money here, and we can have fraction of a whole dollar. So I'm going to use a double. And because the formula uses these values, right? P, R, N, and T, I'm okay with the single letter variable names here. So I'm going to do double P. And that's going to be input.next double. Okay, I'm going to continue on. I got three other values that I need to ask for. As we saw in Hello You, I don't have to repeat step 2, which is constructing my scanner object. I can simply jump to step 3, which is prompting the user. I'm going to use a SOUT, system.out.println, to ask for the interest rate. I want you to think about what data type that could be. Interest rate is a percentage, so we're going to do double. In this case, R is input.next double. Now, an interesting talking point is going to be, do you accept this value as like a whole number, or do you want the value as of decimal already? What am I saying? Do you want this value as 10%, right? The user enters literally 10, or 10%, the user enters 0.10. It doesn't matter which you choose, but just know that you may have to convert on the back end depending on which you use. It's actually easier to ask for 10% like this, because then we don't have to convert it. But do you want the user experience to be better and you want them to enter just plain 10? Kind of up to you. I'm probably just going to take it as a decimal and make it be the user's problem. I'm then going to ask for, please enter the number of times compounded per year. Okay, maybe this should be number of times compounded per year. What data type? Right? Can I have a fraction of time compounded per year? Maybe. But I think an integer makes sense. Because I'm using an integer, I'm going to use next int. Our last little prompt here. Please enter the number of years. And we will get that. It's an integer. Maybe you could have a fraction of a year. I'm okay with that. Let's do a fraction of a year as a possibility. Right? You pull the money out early or something, and that is going to be equal to input.next double. Okay. A lot of stuff just to get our scanner going, but it's the same scanner object, right? Input. I'm just reusing it. I don't have to repeat this step. Once I have the scanner, I can just keep using it. But we're going to start out by telling the users, right? This program calculates compound interest given 4 values: our principal amount, our interest rate, number of times compounded per year, and the number of years. Then we ask for those values one at a time. Now they're in my program. right? They're in these variables, P, R, N, T. I am ready to actually do the whole meat of this, which is calculate compound interest. So I'm going to create a double, compound interest. I'm okay with compound if you want to do that. But let's go ahead and plug in our formula as a comment so that we know what to actually convert. And I think this is a good comment, right? This is our formula. P times 1 plus R over N raised to the NT. Okay. It's P times 1 plus R divided by N raised to NT. This is the formula I want to turn into Java code. If you've just been following along, this may be a good spot to kind of pause and see if you can do this, right? The rest of this stuff is just semantics. It's just us getting started. But this is really what we're trying to get into. I want to take this equation and convert it into something in Java. Okay, so I'm going to take P, in my program it's just a lowercase p, and I want to multiply it by this. So I'm going to do P times, right? We'll go ahead and throw in the parentheses, 1 plus, in my program it is just R, so R divided by N. One thing I like to check for, I see division, I get worried. What is the data type of R? That's a double. Data type of N is an integer. Because R is a double, we won't have truncation, right? One of the operands involved in this division is a double, so we're good. I want this to actually be my base, and this is the exponent, okay? This is where Math.pow really comes in. A lot of the Math.pow we've done so far is just simply like radius times radius times radius, right? That's what it was for volume of a sphere. But here, this is a bit more complicated, and you can see why you have the need for this. This is my base, right? So we're going to do Math.pow. This is the base. I need the exponent. The exponent is N times T. Right? This is my base. This is the exponent. Now, this had parentheses around it because we wanted the order of operations for that to kick in. That's actually going to happen here, right? We'll test it using parentheses around this. We'll test it without, and we should get the same value. But I have converted, I think, this equation into Java code. I'm going to do like I did with volume of a sphere, find one of these calculators online and see if I'm getting the exact same result. But here we go. Final sout. I would probably get something advanced here, right? P. Let's do a dollar sign. P dollars compounded over number of years, which is going to be T. Maybe this should say compounded N times N times a year over this number of years at a rate of plus our rate. Starting to get a little bit too far. Right here is our line that IntelliJ wants us to keep it in. They're suggesting we keep it in. All right, so P dollars compounded in number of times a year over blank years at a rate of blank percent would be, and then let's do our final amount with a dollar sign. All right, I'm going to run this, and you're going to see the output, and you'll see why I'm doing all of this, and maybe that'll help this final SOP kind of make some sense. I'm going to right-click in free space, tell it to run, and here we go. This program calculates compound interest giving 4 values: principal amount, interest rate. All right, I would maybe use an opportunity to kind of explain how I want the interest rate expressed, number of times compounded per year, number of years. Please enter the principal amount. So I'm going to do something like 200. Please enter an interest rate. Think about a normal savings account. A savings account, you're super lucky if you get 2%. Please enter number of times compounded per year. Let's do monthly or quarterly. I want you to think about what that actually means, right? If we're going monthly, that's 12 times a year. Please enter the number of years. Why don't we do like 5 years? Okay, $200 compounded 12 times a year over 5 years at a rate of 2% would be this amount. That looks pretty good. Let's test it. I'm going to find a compound interest calculator. These are kind of abundant because compound interest is used for all types of loans, right? We're talking car loans, house loans. Initial investment, I'm going to test the same numbers that were in my program. 200. Monthly contribution. This is giving you the option, how much money are you adding to it as you go? In our case, nothing. Length of time in years, we're doing 5 years. Estimated interest rate. See, this is what I mean. Do they want it expressed as that? Do they want it expressed as that? We'll see. I bet they want it at 2. Nah. Let's try this one first. Interest rate variance range. Does this update? Does this change over the time period? For us, no. I don't even know if we need a 0. Yeah, let's do 0. And compound frequency annually means only 1 time a year. Let's do monthly. And I'm going to calculate that. $200.20. Maybe it should be 2%. There we go. Okay, that sounds right. Okay, we would amass 21 whole dollars over 5 years. Let's try this again. I'm going to run my program again. Just try some different numbers to kind of show you. All right, principal amount. Let's do $1,000 this time. Interest rate. I kind of want to keep demonstrating this simple 2% interest rate because, again, that's kind of what savings accounts are like, just to give you an idea of how often this stuff happens. Number of times compounded per year. Let's change this up. Quarterly would be 4 times a year. And number of years, let's do 10 years. Right, $1,000 compounded 4 times a year over 10 years at a rate of 2% would be this amount. I'm going to cross-reference these numbers. All right, let's go $1,000. We're not adding in any additional money. Let's do 10 years, same interest rate, but let's go quarterly. Oh, it's not there. Rip-a-roni. We'll do semi-annually. Interest rate 0.02. Number of times compounded per year 2. Semi-annually. Number of years 10. This should be our number. And I believe that's what we got. Oh, I won't let me just throw it in there. What do we got here? 1,220. That's what we got. So our compound interest is working. I'm going to scroll back up, give you one last shot of the source code, a good solid pause slide. But this has been Compound Interest. I'll see you in the next one.